Good. When we started thinking about the topic and what to talk about this and how to title the presentation, we thought about the level of happiness, of extreme happiness that we were having in terms of using and our journey to machine learning with a purpose. And we titled this presentation Cloud Nine. That's the sense of extreme happiness and euphoria that we feel in terms of our use case. I'll agenda. I'll talk briefly about who we are in Todo Uno, why we are using Nime, what is a summary of our use case, our main use case, what are the results and how our Nime plus the cloud journey has been, and close with some challenges and next steps. Our mission in Todo Uno is basically to humanize the relationship and interaction between customers and their financial institutions. And we do that through our digital banking multi-channel solution. We've been out there for over 20 years, coming out of the DNA of Latin American banks. Just to bring some perspective, or talking about digital channels, this is basically the years of the baby Nokia and way before RIM and Blackberries existed. We have over 500 employees in LATAM in the US. And obviously this is a drop in a bucket for US institutions, but we process over 5 billion transactions a year for over 13 million digital customers. When we started doing this, we were relatively new to the public cloud. We have been operating, data centers and on-prem services again for 20 years, but we were new to the landscapes of cloud and machine learning as a whole. Now, why did we go with Nime? And I think we in the end we decided that we wanted to have one platform to rule them all, to be able to bring together the SAS lovers, the R lovers, the Python lovers, or haters, dependently of who you talk to. We wanted to have one place where we could develop everything and collaborate. The other thing that prompted us fast into Nime server and to try to deploy this in the cloud was the availability of REST APIs. We knew that for our first use case, we wanted to be able to deploy the services right away. We also fell in love with the process of having a framework that was self-documented. And I think just the previous presentation you just heard dwells a little bit into that. We also felt, and to be completely honest, we're not getting a discount out of this, but we thought that the sales process was very, very neat. It was centered on our needs as customers, and there is no pressure whatsoever in terms of signing and getting everything going. And last but not least, the price. Your product not only rocks, but also is the best bang for the buck that at least that we could find out there, at least in our opinion. Now, what has been our use case? Our use case is an anti-fraud. We call it Profiler, and we'll try to mitigate transactional fraud in the digital interactions between customers and their financial institutions. And transactional fraud, just to bring it into perspective, we're talking basically, login, password changes, information updates, and obviously transfers, where somebody wants to take over your account, has your information, and is posing as you, and you want to be able to challenge those operations or deny those operations if you feel that those are not from the real user. We wanted to leverage out of all of this transaction that we had, customer behavior, device information, fraud patterns, just massive amount of information, throw that into an appropriate machine learning framework, if you will. And I think this were the key words of our solution, to provide real-time decision capabilities for fighting fraud, where real-time and capabilities were really key words. We wanted this also to be able to be integrated into our solutions, but also to be available as a standalone product. And we wanted to have, and this is a service that we fully host and fully maintain, so it's not just a piece of software that we hand out there. This is fully hosted and serviced by us. Now, why was this project or this use case interesting for us? So, well, first of all, there was a real need. We had real customers, but also the problem was interesting. Even to start from a data point of view, significant transactional, behavioral, device fraud data is really hard to find. You're not going to find production grade data in shared domain out there. Feature engineering was posing as a really interesting challenge. When people think about transactional systems, you think about this absorbing transactional data, but in reality, you have to look at a lot of the context that is around those transactions to be able to come up with a production grade system. And one of I think the first moments of silence that we had in our conversation with Nime was when we started saying, look, we need response times in less than 100 milliseconds. So you can think about this user having a phone and wanted to log in or wanted to make a payment. We don't have the luxury of time and every millisecond count. The sheer volume also made it interesting. When we started working this with Nime, we were talking up to 200 transactions a second. Now we're way over 300 transactions a second. So it's the problem, we've been able to scale it properly, not just along with Nime, but also in the implementation in the cloud. We're also talking about, just because this is a real-time system and it is mitigating fraud, downtime is not an option. If we are down 5 minutes, 10 minutes, we start to get phone calls, and we have very stringent SLAs with banks. We also wanted to accommodate a system that would scale to different type of institutions. We have generic models for smaller institutions, smaller banks, and we have custom-made models for bigger institutions. And we're talking, in the realm of about 50, 60 models that are currently deployed within the solution as we speak. Now, how was the journey into the cloud, and what were the results, and what were the things that we tested at the beginning? Well, we were kind of interesting start because we started in AWS. We deployed very fast. It was easy to test. We tested scaling. How to basically benchmark this to understand the limitations and to optimize. Do we go with X amount of instances, or do we scale up? Do we scale laterally? How do we get this to be a high availability system? Those were challenges that we started facing and testing and working in AWS. And we later on made a decision to move to Azure. So experimenting in AWS wasn't enough of an experiment. Now we had to move into Azure, and then we had to re-optimize this for real-time challenges, bursts of transactions that we didn't have in the lab in AWS. We started experiencing that in Azure, and we had to fine-tune our solution after that. I want to definitely bore you with a chart of an architecture, but right now we're running with a load balancer, 4 Nime servers running RabbitMQ with 2 executors on those servers. We're not sure if that is the best architecture. It is an architecture that has worked very, very well for us. It renders to further scaling, and we're also looking forward to other things, and I'll mention that in the closing remarks. What are the results? Because I'm a firm believer that machine learning and data science without actionable results is just a cost. It's just a toy. It's just big guys playing with big budget. This is something that has been operating for the past 3 months in production, or over 9 months combined, if you combine all the pre-production time. In this past 3 months has managed over 650 million transactions and has had 0 downtime. And I need to stress that because it is important. This is not something that is batch processing, that we have the luxury of taking down and just change to deploy a new model or to deploy a change in a model. This is something that has to be done. You need to fix the plane while still having the plane in the air. We have success cases with 2 banks that have over 8 or 2 million customers with 200 or 100 transactions per second at their peak. And the performance that we get out of the models designed using Nime are twice detection rate compared to a market leader with the same false positive rate. So we think we have a very interesting model in our hand, or solution in our hand. Round trip median time is about 100 milliseconds, so that closes what we devised to accomplish at the beginning. And we didn't need any recoding or the mobile or the web apps of the banks, so the implementation and deployment was really, really fast. Now, what are the challenges and next steps that we definitely want to follow? And I'll close this presentation with this slide. Basically, we are interested in trying to optimize infrastructure cost. We all know that being on the cloud is really, really easy, but it's also really, really easy to get spooked by the bill when the bill arrives. So I think we in this case, our testing of Nime Edge, which is an interesting way to see how we can have auto scaling and scoring this with a much lighter version, if you will, of Nime server at real time. We want to accommodate challenger models into production so that models that maybe the next generation of the models that are currently in use can be tested real time as well in parallel. We would like to obviously improve runtime performance. If you can save a couple milliseconds there, a couple milliseconds there, you're talking 5–10% of improvement in execution time, maybe through use of some proprietary nodes. We obviously want to dwell into more and different use cases. We know that our current system will grow in terms of the capabilities, but other use cases will be interesting to tackle, and obviously evangelize other users in the organization in terms of using Nime. That's what I have as a presentation. I'm not sure, Jim, if I covered my time properly.
Oh, you did great. So perfect. Thank you. Yeah, if you could stop sharing, then I can join you on the screen. Great, thank you. So yeah, very interesting. And you mentioned Nime Edge at the end. So I know we've talked about it, and actually your project is kind of what helped us kick off Nime Edge over a year ago when we talked at Fall Summit. So just what are some expectations for you with Nime Edge as how you could see it working in your current architecture?
Well, in the current digital era for banking and financial institutions, and particularly after COVID, the growth in transactional volume has increased significantly. Number of users and number of transactions per users both. But we see obviously the push in terms of that growth during the day, seasonal events, and we feel that Nime server as a piece is a bit heavy for what it's actually doing. And we expect to be able to, out of the same infrastructure and the cloud, to be able to extract a lot more transactions per second with a lighter version, if you will. And that's the expectation.
Okay, excellent. Thank you. All right, do we have any questions from the audience? Greg, are you there?
I am here, Jim. There's a question that's just come up, and it's wondering if Edgar can talk about what a transaction entails. So if these workflows are running in less than 100 milliseconds, what are they actually doing?
Sure. A transaction basically comes in with what we call an analyze. So we need to score it. We need to very fast understand that transaction can be a login from a customer. That transaction can be a transfer. That transaction can be a request to change your password. And that is happening on a cell phone in Bogota, in Colombia, for instance. And that transaction comes in. We need to score it like really, really fast. And by that, I mean, you take the transaction, you go to your feature database, you extract all the proprietary features that we have in the model, run it through this specific machine learning model device for that transaction, for that bank, for that channel, comes up with a probability turns into a score, and that score just returns blazingly fast to the core system behind it. And then the bank, have rules in place to decide to challenge the transaction, to deny the transaction, or to let the transaction go through.
Okay, excellent. Thank you, Edgar, for being here today. Really appreciate it. That was a excellent presentation, and so hope you enjoy the rest of Nine Summit.
Absolutely. Thanks for having me.